Well, folks, we've been messing with this CNC machine. We think we're doing pretty good here. We're about to, this is the next video in the series. How many videos have we done on this so far, Donnie? 2 or 3?
2 or 3.
So, just to recap, we have a big heavy-duty CNC table here that we bought with a vacuum table and all that on it. It's an old one. We don't know where it came from. We think it might be from around 1999, something like that. Whenever we got it, they had wrecked it, bent the gear a little bit, or the rack a little bit on the side.
This is the rack.
Yeah. And it was missing a bunch of the parts, and it was missing all of the electronics. So we've been working our way through it. So on one video, Donnie drove all the way out of state to go pick it up in the rain.
In the rain. It got wet.
It got wet.
I can't believe I let it get wet. I tried.
Yep.
You need to go back and watch that one. That was a good video.
Yep, that was good. So he brought it to us. And then we wheeled it in. Now, it's on wheels. That's a big no-no for a CNC machine, but we'll take them off once we get it running. And then he figured out how to put the Y-axis back on. Okay, so he got that together. And then we've been looking at the gearing. And we had a problem where we didn't have the right gears. So I didn't know what to buy. So I bought 20 degree, is it surface? Was it surface? Donnie don't remember. 20 degree gears because I bought 14 degree because I thought it's an older one. 14 degree was what the old ones were. But there's also a 20 degree, which is basically the angle of the teeth. There's 14 and 20, okay? So I bought 14 because I thought this is an old one. But the 14s are for the really old ones from like the 50s and 60s and 70s. So since this one was from the 90s, it was actually 20 degree, okay? So I had to go, and then I bought the gears and they didn't have the set screws in them. So we have finally, we think, got the right gear with the right set screw, the right angle, all of that stuff. I thought of the name. It's the pressure angle. Pressure angle. So I thought it was 14 pressure angle because that's what the old ones are, but this one's not quite that old, even though it's old. So we bought the 14 pressure angle on the previous video. We were showing that it didn't quite line up right. And so now we have found the 20 pressure angle, but here's the exciting part. They were the right thing. They were even the right size. Now our other ones were a little bit too small. This is an original one. Yep. So I was buying these and they weren't right. And I had 2 or 3 different types, and we even took them and had a set screw installed and all this.
We had to put the shims on there, these washers like we did last time to make them
yeah, it just is a big problem. So we have found the correct ones. Look at this. And just so y'all know, you're going to want the part number, I'm sure. I know you're so interested in this.
That comes without a set screw.
Look at that. Made in the USA, Martin. TS 2012, that's the part that we needed. And it seems to be an exact match for the one original one that we still had left. Okay? But we had to add the set screw. So we took it to our guy. We got a guy, a machinist who is machining them for us. So didn't we run into yeah, we got another problem here. Okay, so we'll show you the next problem. So we got that, okay? So now think about what's going on here. We have the gear that we actually need. We found it, and we put the set screws in it. So Donnie mounts one on the wheel.
Yep.
Okay.
I put the set screws in.
He put the set screws in. When last we left him.
Okay, y'all, I'm trying to get this set screw back in there.
We got it. There's a purpose for this, folks.
Come on, big finger.
There's a reason we're trying to show you this.
Okay, there it is.
There it is. So here's the problem. Set screws are too long because that has to pass through this hole and then the gear meshes with the rack. But you can't do that because the set screws are too long. But that's an easy problem. So I have bought new set screws.
Look, we got
the moment of truth. Yeah, those didn't fit.
We bought all those set screws to do the job.
That's the ones from China. Didn't work. Where's our good ones?
I don't have no clue.
What'd you do with our good ones, Donnie?
Don't know. I thought they was gonna be in these, but they're not there.
They were in there. They had their own little bag. Okay, we got to find our parts here. There they are. They're in that bag. Okay, here we go. This takes us a while, folks, because we only do it on the weekends. We're just, you know, having a good time here. And so I ordered these set screws.
And then we got to keep up with all this.
Yeah, we called our guy and said, hey, what size set screw did you put in there? And then we ordered some new ones that are a little bit smaller, a little bit shorter, so that they will go in there a little better. Donnie's going to try to install them here.
See, and then we got to do this.
Then we got to play this game.
What tool was it again?
Now don't cross thread it, Donnie.
Try not to.
Don't do it.
Okay, there's one.
Hopefully this will do it.
Now, how many people on there is going to holler at us about not putting a flat spot?
It'll be all right. Don't worry, folks. Don't worry. It's going to be just fine. And you didn't put any Loctite on it or nothing.
Yeah, God almighty.
Amateur.
Okay. Comment below if you think we need Loctite.
Okay.
Oh.
So it has now went through and it's meshed. But there's a little wobble in it though. Why is there wobble in it?
I think that's because I ain't got the back side.
Oh, because we don't have this side of the bearing on. Okay, so
This side goes on.
That goes on like that. We got to put the belt in there.
Yep.
Okay, so that's that. And then the motor mounts up here. There is the motor actually mounts over here. The pinion wheel or whatever they call it. I guess that's the pinion. The wheel mounts on the motor, and then when the motor turns, it turns this gear. So it's figure out which way it goes. So now he's got the belt on. So again, we don't know which model or anything this is, so we're just figuring it out as we go. Look at that. Nice, precise fit. Now turn it with the belt, Donnie. So he's a motor.
Hang on, I'm off rail here.
It's making circles and stuff. Okay, so what have we accomplished? Well, we've got it's the correct gears, we believe. When you run them down the rack now, they seem to mesh perfectly. Here, we'll show them. Look at that. Look how cool. So it's a 20 pressure angle. So we think we've solved that problem. We've even got the part number, and now we filmed a video where we show the part number in it, okay? So here's what we're going to do next. We're going to mount the motor to the Y. We're going to put the gear on the Y, on the Y, and then we're going to mount it back on the Y, and then we're going to see if we can get everything to line up. So basically, we've got all of the gears that we need. We're going to go ahead and install them, and we're one step closer.
Hang on, we got something else here.
What?
You forgot to tell them about these.
Oh, yeah. So these little pulleys. These are XL pulleys. Now, we ran into a little problem. Our motor has a 1/2-inch shaft on it. So we need a 1/2-inch bore. Okay? And the pitch of the belt is XL. Okay? So the belts were still on the thing. So we knew the length of the belt. We're trying to reverse engineer it, right? We knew the lengths of the belt, and you can see it comes up here and goes around a pulley. The motor mounts here, pulley sticks through here, and that's how it works. So it's an XL belt, so we need XL pulleys. So first we got this bad boy. Now this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this is a 18 tooth or something like that. Too big. Got the 1/2 inch bore though, but it ain't gonna work. Basically, if you put it on the belt and stretch it for them there, Donnie, so they can see why it won't work. Oh, you're off the...
Ronnie was like, damn, it might work.
Yeah. Okay, so see how the pulley won't go to the center? So that's obviously not the right one. So we need one that's smaller in diameter, go up a little more. So here's the deal. That's a 60 tooth. So I'm thinking in my head, it's a 12 tooth pulley. So we need a 12 tooth, that's 60. That would be a 5-to-1 reduction. That's probably what it is. So for every 5 revolutions of the motor, this would revolve once. The gear is about, I think it's 2.7 or something like that inches around. Maybe not quite that much. 2.5 inches around. So if this turns one time, you move about 2.5 inches. Something like that. We can measure it. You got a tape measure, Donnie? Yeah, that's going to be more like 2 inches. A little over 2 inches. He's grabbing a tape measure. We'll see. All of this math. Did you know there was going to be a math test today, Donnie?
No, didn't know.
All of this math.
And I didn't know we was going to damn play find it.
Tape measure?
Tape measure, there it is. I got it. I'm coming.
Nope. Well.
Okay.
Okay, we're a little far. Bam. Measure from there to the center of that bolt. Yeah, about 2 inches. A little over 2 inches, maybe.
2 inches? You could have done that with something else.
We're trying to keep it. It's supposed to be, Donnie. It's supposed to be. It's supposed to be family oriented.
Framing square.
I'm gonna have to edit this out. Okay. So so our thought is this turns 5 times if it's a 12 to make this turn 1 time, which makes this turn 2 inches. Okay. So you get 2 inches out of 5 revolutions of the motor. 5-to-1 reduction. So I got a 12. Well, I couldn't get a 12 because they don't make them with a 1/2 inch bore. But we don't know that the motor definitely had a 1/2 inch bore. Again, we're trying to figure all this out. But the motors I wanted to get have a 1/2 inch bore. Okay? So on a whim, we bought a 15 tooth.
15.
So a 15 tooth, if you think about it, that's 4-to-1 reduction. That makes sense. It could have been a 15. And would you look at that? Bam! We figured it out. It must have been a 15 tooth XL pulley and our 60 XL pulley. That must be how it originally was. And what helped us was we already had the belt, but I mean we could have figured that out too. Because if you've got a 15, like we could have put a bigger pulley. I guess if we would have got a bigger belt, it would have worked. Yeah. Okay, so the belt helped us figure out how it must have been. So they have 4-to-1 reduction, so 2 turns moves you about 1 inch. So you're getting about 1/2 inch out of each revolution of the motor. So why do you need to know that? Because we're trying to get this where it runs faster than our other ones. So we just had it in our head that we wanted to run rapids at about 600 inches per minute. It don't really need to be that fast because it's only an 8-foot table. So, I mean, really, how fast can it run on 8 feet? But if you're trying to shoot for like 600 inch per minute rapids, and now we're running an inch for 2 RPMs, 600. So 600 inches per minute, we would need 1,200 RPMs to run that fast. That ain't going to happen. Am I doing that right? I'm not doing that right, am I?
Somebody will comment and let you know.
Yeah. No, let me think. Okay, so 1 RPM is half an inch. Okay? We want to go 600 inches a minute. That means we need 1,200 RPMs to do that. That would never happen. We're never going to get 1,200 RPMs out of it.
1,200 ain't that much.
No, I mean out of the motor. The thing is, whenever you run a motor at like a lot of RPMs, the torque just goes down so low you're not going to do that. But we'll mess with it. So, huh? Yeah, it's the rapids, but still. Okay, so we have picked a motor that we're going to test if we can get this sucker running. Now, Donnie's over there putting the other gear on. So I bought one motor so we can go ahead and test it and see what's going on. So we have already mounted that one here on the Y. So our 15-tooth pulley, 60-tooth pulley, belt. Now the belt is pretty tight, but it's kind of got to be tight if you're going to have any kind of precision on it, right? Okay, so here is our motor. The main problem I had was I'm trying not to go with Chinese motors, and this is a Japanese motor. Okay. So I don't know if I've got the details of this thing here. Let me see if it's got if it came with anything. But here's our part number. Okay. So let me see if I got the manual with it. I do have a manual with it, but it's just generic stuff. So we'll have to look up the part number. I'll look up the part number and show you a little clip of the like the torque curve and all that stuff for the people that are curious about that kind of stuff. But I specifically picked this one because you got a little bit more torque at a little bit higher RPMs. So we'll see. All right, Donnie has got the other side tapped on. We've only got one motor though, so we're not going to get all this. And the electronics is still half done. So, but this is, we're just working towards the next step. We're trying to systematically test it out. If we don't like the motor, we'll go with a bigger one. From what I understand, those are NEMA 34s. Here's my understanding of it. Y'all can chime in below that know more about it. A lot of people make the mistake of going with the biggest damn motor they can find that's got the most torque. But the problem you run into is the torque drops off drastically as soon as you start running it. And we're cutting wood. We don't need a whole ton of torque. What we need is for the torque to stay a little more steady at the higher RPMs. So we're trying to balance that, where you don't necessarily want high torque that you immediately lose, but you don't want something so weak that it doesn't have much torque. So we went with this one. I think it's a little bit higher quality motor than some of those big. They make the big old long freaking motors with a lot of torque, but they don't have a lot of torque once you're running 300 or 400 RPMs.
We need to run double that too. 1,000 RPMs at least.
1,000 rapids though, so I don't know. We'll see. All right. All right, we've mounted the Y back on. Well, give her a little push, Donnie. Oh, it's because, never mind. We got the motor hooked up. You're trying to turn the motor. I was thinking, man, what in the world? It's because you're basically turning the motor by hand. What do you think?
I think it's going to take some pressure.
Well, good. I think we're good. It's smooth.
It is extremely smooth.
Basically, the motor, like I said, it's not really high torque, but it does have a pretty good amount of holding torque. So basically, you're trying to overcome that by you want it where when the motor is just sitting there, that basically the material is pushing back against the motor, so it needs to be strong where it can handle that. So with the motor hooked up and the gear reduction, it takes a little effort to move it. but I believe that's right, and it feels smooth. So, you know what I think, Donnie?
I think it's time.
I think we've got all of the gears fixed.
I think we might have it.
Running gear here. We don't have a motor yet, though. On the other side, running gear, but don't have a motor. We got the rails. And then here we've got the rails and the gear. Actually have the motor hooked up, just don't have it running yet. And then our Z. We're not necessarily going to use this, although I might. I'm going to look into it and just see what it is. But the Z is a ball screw, actually. That shouldn't be moving, Donnie. We've got to. Yeah. We don't have that mounted.
I got it screwed in right there.
Yeah. So it's a ball screw, which we'll probably run with. We may be able to use this motor with the encoder on the back, or that's just a an NEMA 23. We may replace it too, but here's that part number just in case you're interested. So I'm going to look that up and just see what we're working with there. Don't we have a couple more of them too?
We've got just the actual motor itself.
I thought it came with some stuff. Yeah, we got another one. Seen better days, you know what I mean? But that's fine. It's supposed to be like that. It's just a 2-shaft motor.
It's locked up.
Oh, is it?
Well, it don't turn as easy as that one.
Oh, okay.
And it ain't turning at all, so it's locked up.
Yeah, but I don't know what that would have been too. I think maybe they had different Z-axis setups that they could mount to it, because we've got some other plates and things. And that huge spindle mount there. And it came with this huge spindle too that we're not going to use because we don't know anything about it or whatever. And just for the comments, somebody was mentioning that we should put servos on it. We may do that down the road, upgrade to servos. But we're kind of just trying to learn and figure out how to build the thing, and if we decide that it's not going to work for us, we can do that later. But there you go. So in the next video, we're going to try to wire up the electronics, or start wiring up the electronics, build our box, and then see if we can get that motor to run. We're going to be running it with Mach 3, which we're using to run our other one. We're basically just going to set up another profile in Mach 3 and see if we can get the Y to move. And then we're going to see what kind of, just how it performs and what kind of speed we can get out of it. But we won't be able to cut yet or anything, of course. And then we'll order the other 3 motors from there, or 2 motors and maybe a 3rd one. So there you go. Hope you enjoyed it so far. So what did we accomplish, Donnie?
We got our gears on.
Got our gears ordered, the right ones, and we found the right pulleys. We were even able to mount a motor.
Got all my set screws in, got all my stuff together.
Got the set screws right. So we're, I think mechanically, we've gotten there. Now, electronically, or electrically, we still have a long way to go.
Long way.
And we still got our cabling and stuff to figure out, so. But it's getting there. So it's slowly going back together. After we get it all back together, we need to build a vacuum table. It has the remnants of a vacuum table, but we need to fix all that. Stuff missing and broken and all of that. But I think step by step, we're getting there. What are you doing?
Trying to get out a set screw that I dropped in the hole.
Oh, okay. All right. So there we go. All right, Donnie, tell them what to do.
Y'all subscribe to the channel. Give us a thumbs up for filming it. Y'all are here every week. You give us a thumbs up. You know, thumbs up really helps the channel out. It does a lot for us. Give us a thumbs up.
This is the type of content you don't get from other people. They show you their nice, pretty CNC machines that they spent $30,000 on and had delivered in a box and then bolted together.
Yeah, we didn't do
Come on, people. Come on now. This is unique content.
And then subscribe to the channel. Subscribe. And have your friends subscribe. Call somebody, tell them to subscribe. Now, we're trying to get on up there. We need a couple 100,000 people. So just tell all your friends to hit the little subscribe button. Now,
They can only hit it an odd number of times.
No, The subscribe button?
Yeah, if
Yes.
you hit it an even number, it's real bad.
Yeah, hit an odd number.
So you can hit it 3 times. Don't hit it 4 times.
Don't hit it 4. And give us a thumbs up, subscribe to the channel, and we'll catch you on the next one.